This is coming to you from Emitech Engineering Service Limited. Today I'm going to discuss about ATS, that is Auto Transfer Switch, which in simple understanding, auto changeover. Before I go on this discussion, I want you to understand what I mean by auto changeover system, or how the changeover system operates, and what it's all about. If you look at the screen here, you see a little diagram of a simple ATS, the block diagram. On this diagram, this is the two source of power, while this is the mains, the building, the factory, the hotel, whatever is here. So on this video, I'm going to use this side, one source of power as a public source of power, then the other side as generator source of power. So as I said before, ATS, what it does is that it signals two sources of power. When one is running, it's signaling the second one. Once the second one comes in, it will drop this first one and engage the second source of power on its own without any manual operation. This is an ATS. On an understanding. So on this little video is a panel that was built by Emitech Engineering Service using Deep Sea Electronics. This Deep Sea Electronics is a complete ATS. It has the capability to change from generator to public power on its own without any manual help. Then I'm going to explain this Deep Sea a brief for you. This Deep Sea you see here, on this upper side you have line 3, line 2, line 1 and neutral. Is always a public source of power. Then this is a contact of this source of power. Then this is the generator source of power. Then this is the contact, and this is the run relay. That it shows you that one of them has been closed. Then once this system, maybe you are running your generator on this side, it closes this contact. Once your 3-phase here is complete, if it's 2-phase, it will not close. But once this 3-phase is complete, it closes this contact and then this contact also, on a design or on building this system, you have to run a contact, the source, which I'm going to show you here. The contactor or the motorized breaker must have to be two. One for the generator, then one for the NEPA. As the drawing shows before, you run your income separate. This one goes on its own from generator cam, then this one from NEPA com, and you have your common output. So if any of these ones closes, your output will go to the building or wherever you assign it to. So the coil of this contact has to be break to this man. So that once this closes, it closes that one. Then the second one has to be break to this. Once this closes, it closes that coil and the building will be energized. So that is this. So then for this is a probe where you set the timing. How long will it stay? Will it sense the source of power before it will produce? This is what this does. This is for public power, and this is for generator power. Then this X1 is also, everything about here is for public power, this is for generator power. Then once your first light up is blinking, if it's blinking, it's showing you that if this is blinking constantly, which means there is power here, but the phase is not complete. But once this is steady, this light is steady, that shows that NEPA is available. Then when that public power is available, this your timing reaches, it will close this breaker and this light will come up, showing that the power is energized. Then this is what is called run relay. This has to go through a relay. This is a close contact. It has to go through a relay. So that relay will now come up, maybe to bring up your own indication light, to show that there is power already, there is an output given. So this is how this system DC electronics model, this model works. Then in this my design, you find out that it has so many other components. Yes, why I put this component is that I has a provision for override of automatic, that you can use your manual to operate this system. So in this manual, once this contactor closes, your public power coming. When this one closes, your generator power comes in. Why these ones are just for protection. This is the breaker that protects the public power. This is for your generator, and this one protects this run relay. So these are connectors. Okay. I'm going to show you the front. This is the front of my panel. When I say override, once you press this emergency stop, it overrides the automatic side of the operation, which means you have to turn either turn on this switch to generator and press your start button. Generator will be energized, or you turn this and press and public power will be energized, showing you the one that is available. And this is load run, that is load you have been engaged. So in this my design, there has been an existing contactor in the system before this was built. So that this coil, this is the coil of the existing contactor. I have two of this coil. One is for NEPA, one is for generator. This particular is for public power. So that's the output that is coming from my panel will just come for the one on generator. Once the generator side closes, it comes here. Once the NEPA closes, once the public power closes, it comes to the public power. Then this contactor will close. Then once your generator on, then this is a overview of the existing panel. So I just come and put this is for public power and this is for your generator power. I will just come and feed this as load to my panel. Meanwhile, this will now feed the building. So this is how the simplest way to build ATS using the DSE, that is Deep Sea Electronics. This video is coming to you from Emitech Engineering Service Limited. Please, you can call us for design, for training, for any sort of industrial jobs. We have a trained staff and we're there to help you. Please don't forget to subscribe so that you have so many of our videos, and also tap the like button. Thank you.